Hey all, I am K.Harshith. So in my previous video, I have given the fundamental idea on Doppler effect, and I have given you the formula, the main important one and only one formula in Doppler effect, and then we have seen the sign conventions of the Doppler effect. And then according to those sign conventions, how is the general formula changing? We have even seen that case also. Now here we will see different cases in Doppler effect. What are the different cases? Let us observe these cases now. Right. So let us observe the first case in Doppler effect. When the source is moving towards the stationary observer or object, anything is fine. When the source is moving towards the stationary observer, let us draw the small pictorial representation for the same. This is the source, this is the object. As already discussed in my previous video, the velocity of the sound is then always from the source to the observer. This is v, and the case what they have given is saying that source is moving towards the stationary observer, and can I say the velocity of the observer is 0 because they said stationary observer, and they are saying source is moving towards the stationary observer, which can I say source is moving in this direction, like this it's moving. This is Vs, correct? Now can I say Vs is some value? We don't know. Okay, Vs is positive or negative. What will we say? Vs is positive. Why positive? Because Vs, velocity of the source, is in the direction of velocity of the sound. When the source velocity is in the direction of the velocity of the sound, we take it as positive, correct? VO is 0, Vs is positive. Now, what is the formula? What is that is there for us? N dash is equals to N into V minus VO by V minus Vs. Correct? This is the formula that we have. Now here, VO is 0. Let me modify here. N dash is equals to N into VO is 0. So V minus 0, I can just write simply V. Correct? And then V by V minus of plus Vs. V minus of plus Vs. So minus into plus will remains minus only, correct? So when the observer is in stationary mode, then the n dash, that is the apparent frequency the observer will listen, can be calculated using this formula. Right? Now suppose they are asking the wavelength. What is the wavelength? We have the formula, okay, from the basic, V is equals to N lambda, correct? Where N is the frequency, lambda is the wavelength, and V is the velocity of the wave, correct? Now in the place of N, can I write V by lambda, can I say? Right. Now in the place of N dash, can I write V by lambda dash? In the place of here N again, can I write V by lambda, can I say? And now can I say V, I am adding the same, this I am adding the same, this is there is no change. Here V and V are same, so V and V are cancelled, correct? Now 1 by lambda dash is equals to 1 by lambda into V by V minus Vs. This invert lambda dash is equals to lambda into V minus Vs by V, correct? So here lambda dash is nothing but the wavelength, okay, the wavelength. From the frequency we have calculated the wavelength. Just invert the formula of the frequency, you will get the formula of the wavelength, okay? So this is the formula of the wavelength, please note it down. Lambda dash is equals to lambda into V minus Vs by V, okay? Now let us come to the second case. Second case is nothing but just opposite to the first case. What is the first case saying? That the source is moving towards the stationary observer. Here I am saying source is moving towards this is away, moving away from the observer. I'm cutting down the derivation because it's the same thing, but just the sign convention changes, okay? So I'll cut down the derivation, okay? We'll draw the pictorial diagram here. This is the S, this is the O, always V is in this direction. Observer is, they gave 0, stationary observer, this moving away from the stationary observer, because we are doing initial cases, so we'll take stationary observer, okay? Stationary observer, right? Now here source is moving away, means in this manner, can I say? Yeah, in this manner, away from the velocity of the sound, opposite direction of velocity of the sound. So can I say the sign convection is minus, can I say negative? Yes or no? Now we'll directly get the formula. N dash is equals to n into v minus vs by, sorry, v minus v naught by v minus vs. Here v naught is 0, v only, vs is negative, means can I say negative of negative, means can I say it is as positive? Yes or no? So n dash is equals to n into v by v plus vs, correct? Coming to the same wavelength, just reciprocal of the frequency is wavelength. Lambda dash is equals to lambda into v plus vs by v. This is the frequency, this is the wavelength. What is this case? When the source is moving away from the stationary observer. Fine. Similarly, third case, same again. When here we are taking stationary source, when observer is moving towards, let me say, towards the stationary source. Okay, when the observer is moving towards the stationary source. Now let us guess what will be the condition. This is the source, this is the observer. We are not changing their dimensions. Okay, you can of course keep source here, observer here, but I am taking in this way. Okay, the velocity of the sound is in this manner. Source is 0. Okay, I'm going a bit fast because we have understood these two cases. Then these are all are nothing but just manipulation, we can say. Okay, so the source velocity of the source 0 because they said stationary source. All right. Now next, if you observe here, object is moving towards the stationary source, means can I say in this direction? Now very careful with the sign convention. VO is positive or negative? See, it's moving opposite direction, so VO will be negative. Remember, whenever the velocity of the object or source is moving in the opposite direction to that of the velocity of the sound, what I am saying, when the velocity of the object or the source is moving in the opposite direction of the velocity of the sound, then the sign convention will be taken as negative. Fine, it's moving oppositely to the velocity of the sound, so we have taken negative. Now directly writing the formula, n dash is equals to n into v minus vo by v minus vs. Okay, this is the formula. If you know this, anything means anything can be solved in Doppler effect. Okay. Now here Vs is 0, means shall I say denominator only V is left, correct? And here up on the numerator V minus of minus VO, because VO is negative, correct? So minus of minus VO will in turn into plus. I hope you understood this thing. It's nothing but V minus of minus VO. Minus into minus will give plus, V plus VO. The same thing I have written here, okay? Nothing else. Right, this is the frequency. Coming to the wavelength, lambda dash is equals to lambda into v by v plus v naught. Clear? The same thing. Now another case is there, which is brother of this case, that is observer is moving away from the stationary source. Let me even draw it, do it here itself, so that we can close the stationary part, and then we will next see both the source and the observer are moving. That cases we will look at. Okay, so here only I am closing this thing. Source, observer, I hope it's visible. Okay, yeah, it's clear. Source and observer. Okay, this is another case which is just the replica of this. In this, try to understand in the pictorial form. This is the velocity of the sound. Okay, here there is the source, here there is the observer. The observer is moving away from the source. VO, Vs is 0. Okay, observer is moving away from the source. When he is moving away, means he is going in the direction of the velocity of the sound. So can I say VO will be positive itself? Can I say this? So better let me write it. This is when the observer moves away from stationary source. Clear? That's the case that they have given for us. Now, coming to what will be the forms here? N dash is equals to N into V minus V naught by V minus Vs. Correct? Come here. VO is positive. Means can I say this like this? V minus of plus VO. Correct? Which will in turn be V minus VO. Correct? So here can I say it will become minus only. It remains as minus only. And here Vs is 0 because they said stationary source. So here just V is remaining. Similarly for lambda dash case, lambda dash is equals to lambda into V by V minus V naught. Correct? Done. Now very careful. Sorry, here we have done. Yeah, it's correct only. Yeah, that's it. Okay. So, what's the difference? Only minus and plus. Minus and plus matters a lot in maths and physics. Please do remember that. Okay. A small minus and a small positive charge may change the value entirely. Okay, from negative to positive. There will be a lot of variation. Okay. So don't see that, oh, it's only a sign convection that is there. What's nothing to worry? No, sign convections are very important. Okay. Right. That was case 4 completed. Now coming back to case 5. Okay. Fifth case. When observer and source are approaching each other. What do you mean by this? Approaching each other means what? Very simple. Here the source is present. Here the observer is present. Correct? Now approaching each other means source is approaching towards the object is approaching towards the source. This is the meaning of approaching each other. Okay. Now always fundamentally saying that the velocity of the sound is taken from the source to the object. Now as I already said, this is in the direction of velocity of the sound, so we will take Vs as positive. This is opposite to the direction of the sound, we take Vo as negative. Clear? Okay. Now next coming to the formula. What is the modification in the formula? N dash is equals to N into V minus Vo by V minus Vs. Okay. Here nothing is 0. Not even Vo is 0. Not Vs is 0. Now let me manipulate here only. Vo is negative. Means can I say V minus of minus V naught, which will become V plus V naught, correct? So this will be turned into plus V plus V naught, and here it remains minus only. Why? V minus of plus Vs, which means V minus Vs. V minus Vs only. Okay. There is no change seen in the denominator. Now coming to lambda dash. Lambda dash is nothing but lambda into this goes upside. V minus Vs by V plus V naught. That's it. Simple. Okay. Coming to case 6. That's case 6 is the brother of case 5. Can anyone guess what will be the case 6? When observer and source are moving away from each other. Away from each other. Which, let me draw it in a pictorial form. Okay. So this is the source here. This is the observer. Always this is the direction of the sound, and then both are moving away from each other. Now you say me, what will be Vs? Vs is in the opposite to V. When I said it's opposite, then automatically it will become negative. And this is in the direction of V, so Va will be positive. Now coming to here. N dash is equals to N into V minus V naught by V plus Vs. Can I say this will be the formula? How? V minus V naught. V naught is positive, so V minus of plus V naught will give me V minus V naught only. And here Vs is negative. V minus Vs. Sorry. V minus of minus Vs. Minus. Which will give me again V plus Vs. That's it. Okay. So this is the formula for the frequency. Now coming to the wavelength. Lambda dash. Lambda dash is equals to lambda into V plus Vs by V minus V naught. This is the for the wavelength. Why I called it as brother? Observe. Compare this and this. This is just the reciprocal of this. Observe. Here it's minus V naught. Here it's plus V naught. Not reciprocal. Here it's plus V naught. Here it's minus V naught. Here it's minus Vs plus V. That's why I call it as brother of the case 5. Okay. Fine. So now next let us discuss two cases which are special. Okay. Now you will only say me why are these called special. Okay, let me write down the case number 7. When source and observer are at rest. What do you mean? Source, observer, velocity. Source is at rest. Good. Even the observer is also at rest. Now what is happening? This is not O, this is 0. Okay, both are at rest means both I am taking velocity as 0 meters per second. Okay. Now the formula is n dash is equals to n into v minus v naught by v minus vs. Can I say? Now here vs and v naught are 0. N into v minus 0, v plus 0, v minus 0. Sorry, v minus 0. They are not moving. Original formula mein, if they are moving, then we are taking sign convection. They are not at all moving. We are not taking the sign convection. We are just taking the original formula and substituting. What? VO is 0, VS is also 0. Now you see me here, what will happen? V by V, can I say? Both are velocity of the sound, and velocity of the sound are the same. So cancel. So you get n dash is equals to n. Okay. Think for a while why I said that this case and its brother case are special cases. Okay, I will solve even the same case which is just like this. You get the same thing, and then I'll say what is the specialty in it. Okay. Okay. Now what is the next case? The brother case of case 7. That is the case 8. Right. Case 8 says when source and observer are moving with the same velocity cities. Okay, this is the source, this is the observer. Okay, this is the direction of v. Source and observer are moving in the same direction. Now here you need to get both as negative only. The formula should remain v minus v naught and v minus vs only. Means shall I say this is moving in this direction, this is also moving in this direction, correct? Then only the formula remains the same. So let me modify the case. Source and observer are moving in the same velocity in the same direction. In the same direction. Okay. Now n dash is equals to n into v minus v naught by v minus vs. Correct? This is the formula. Is there. Now here v naught and vs are same. Velocity of the observer as well as the source is same. So I am writing the general. Generally I am saying let v x is equals to v naught is equals to vs because both are same. V and vs are same. So I am writing generally both of them together. I am writing vs. So v minus vx by v minus vx. Okay, both are same here. Sick v minus vx, v minus vx. Cancel. Again you get n dash is equals to n. Now suppose if these are moving in opposite direction, then if suppose the source is moving in opposite direction, you get here positive v plus vs, v plus vx. The special case will not come into picture. Special case will only come into picture when both the observer as well as the source are at rest, or both are moving with same velocities in the same direction. Now look here. Here also we got n dash is equals to n. Here also we got n dash is equals to n. So what is n dash and n? N dash is the is the apparent frequency or the frequency heard by the observer. Source n is the frequency produced by the source. Here also same. The whatever source is produced by the source, the same amount of frequency is heard by the observer. So here Doppler effect will not come into picture. Why? Because whatever is produced is heard back again. So henceforth, for these both cases, no Doppler effect. No Doppler effect is seen. There is no Doppler effect seen in these two cases. Okay. Now you may get it out. Is it that always the source moves in the straight line? There is no guarantee, right? Source may move in this direction. It may make an angle theta. It may move in any angle. Correct? It's not that source will always move in the direction of the straight line. In the straight line, no, there is no compulsion in that. So what if case number 9? What is case number 9? When source is moving in moving um, with an angle theta, with an angle theta with the with the axis, with the x-axis. Okay, let me draw the pictorial one if you are not getting the idea with what the statement what I wrote. Suppose that this is the source, this is the observer. Always this is the direction of the flow of this velocity of the sound. Correct? Now, suppose, say, according to the case, source is moving in such a way that it is making an angle theta with the x-axis. This is the x-axis. It is making an angle theta with the x-axis. This is the case that is given to us. And then also provided here that they didn't mention anything about observer, so we will imagine that velocity of the observer is 0. Next case we will even see when the observer is also moving. We'll see that in the next case. Presently now we will take that velocity of the observer is 0, means the x-axis, that is, and observer is at rest. Observer is at rest, right? Now, the general formula, what's the general formula? N dash is equals to N into V minus V naught by V minus Vs, correct? N into V minus V naught is 0. So it remains as V only. And V minus Vs. Now come into Vs. Okay, this is Vs, correct? This is the Cartesian plane that I am taking. Okay, this is an line passing through origin making an angle theta. Okay, now you say me, suppose say this is a, it's a, okay, units are a, it's moving, distance moving is a. Now you say me what you will take on x-axis, what you will take on y-axis. On x-axis, theta touching side will be taken as cos, don't forget this will write as a cos theta and this will be written as a sin theta. Theta touching side is cos. Okay, theta touching side is cos. Now here Vs, theta touching side, it's making an angle theta with the x-axis. So theta touching side is nothing but cos theta. So instead of Vs, I am saying Vs cos theta and dash. Got it, everyone? This is the minor change that is seen. Okay, right. Now we have, now let us write the brother of this case, case 10. Okay. So if you understand these cases, solving the problem will be very easy for us. Okay, that's the reason why I'm making you write these many cases. Okay, so in the cases we'll cover most of the concepts. Coming to case 10, when the source, or better say, I'm not writing the case, I'll represent it in a pictorial manner. Okay, you may write it in your own words if you want. Source here, observer here, correct? Now source is moving with along the making an angle theta with the x-axis. It's moving towards the observer, whereas observer is moving towards the source in this way. It's making an angle theta. Let me say it's making an angle alpha. Okay, it's making an angle alpha. It's making an angle theta. Clear? So now always this is the direction of the velocity of the sound. Correct? Now practically it is moving like this. Can I say like this? Actually, it is moving in the direction of velocity of the sound. Yes. So Vs remains positive only. Coming to Vu, this is the velocity of this direction of the velocity of the sound. It is moving in this manner. Look. So can I say Vo is negative? Formula changes. Sign convention and formula changes. How? Very careful. N dash is equals to n into V minus Vo by V minus Vs. N into V Vo is minus. So can I say V minus of minus will become plus? Vo is not Vo. Alpha touching side. V cos alpha. Understood the logic? Here we have taken cos theta. Theta touching side. Here alpha is touching, so cos alpha. V minus only because it's plus, right? Minus into plus minus. V minus V cos theta. Okay, and in this case, if theta is 90 degrees, if theta is 90 degrees, can I say cos theta, cos 90 is 0, v minus 0 is 0, v cancel, again you get n dash is equals to n, no Doppler effect. Okay, I think it's clear. Let me write it again. If theta is 90, then n dash is equals to n, v by v cancel, n dash is equals to n, no Doppler effect. D effect, Doppler effect, okay? No Doppler effect. Just a second. Yeah, no Doppler effect. Clear? That's it. And here also if you're taking 90 again cos alpha and cos theta, then again you get the same case. N dash is equals to n. Okay, I'm not writing it again. Okay? Right. Now we have last two cases left, okay? 11th case, let us observe. I'm not writing again, okay? I'm just drawing the pictorial form of it. Source. There are 3 points A, B, C. Okay? A, B, C. And the observer is standing in front of B. I think a observer is visible for you. Yes, you can observe the observer, right? Here is the observer, here is the B. It's exactly on the line of B. Source is present here. Source is moving like this. Sorry, not like this. Yes. So what we took is correct. Yes. Okay. Source is moving from A to C via O. Okay, passing through it's moving. But O is somewhere here, so we will take these as the directions of the source. Actually, the velocity of the source is in this manner. But sound is traveling from the source to the object. Means can I say sound is traveling in this manner? From the source to the object means in this manner. So here can I say Vs is positive? Sir, no. Now what the formula becoming? For A, n dash A, n V minus V naught. Okay, V naught we are assuming V naught as 0. Okay, for simply understanding the case, Vo is 0. So V by V minus Vs cos theta. Suppose say it is making an angle theta. Actually, the source is moving in a straight path, but as the observer is at the angle theta with the source line or with this velocity of the source line, hence we are taking Vs cos theta. Fine. Similarly, coming to NB, N into N dash B, V by V minus 0 V. Now look here, V minus, can I say Vs cos 90, can I say? Why? Look here. Here it's making an angle 90. Because I said two times what? The observer is on the line of B. Observer is on the line of B. Hence, can I say Vs cos 90? Means shall I say cos 90 is 0? V by V, special case we have done, right? So can I say it becomes n dash is equals to n? N dash is equals to n. Here no Doppler effect. No Doppler effect. Coming to this case. In this case, here in this case, what is happening is, look, when we are taking this case, can I say the source is here now? Source is moving from here to here. Source is moving. Okay. When it's here, we have taken minus Vs. Here we have taken 0. And here when it is here, can I say this is the direction of the velocity of the sound from the source to the observer? Means can I say the velocity of the sound is in this direction, but the source is moving in this direction. So can I say Vs is a negative now? Sorry, yeah, negative now. Yes, here positive, negative. Come again, once again. The source, when it is here, it is moving on. It's not stopping here, it's moving on. When the source is moving on, the velocity of the sound is from the source to the observer. From here it has moved away. So from the source to the observer, this is the velocity of the sound direction. This is the direction of the velocity of the sound. Source is moving in this direction, so we are taking Vs as negative. Coming to here, n dash is equals to n into v, yeah, just v, because observer is 0, by v. Again here also let us assume it's making the same angle theta. Okay, why to change? V minus or plus r, minus into minus, plus v plus vs cos theta. This is of c. Okay, so na, nb, nc we have done. Okay. Okay, one last case. Okay, it's the case 11. Case 11 is a bit different. Okay, what is difference is, okay, again I'm not writing, this is 12, sorry, case 12. I'm not writing anything. Suppose say here the observer is present, who is at rest. Okay, the observer is present here, who is at rest. The source is moving in a circular path around the observer. Okay, this is the source. Correct? Okay, the source is moving in this direction. They have given us at these points the source is moving like this in this path. Okay, when the source is moving in this path, can I say in this direction the linear velocity will be there? Yes, can I say the source is moving in this direction, that is the linear velocity omega, but the angular velocity, when it is moving in this direction, the angular velocity is in this part omega, but the linear velocity is along the tangent. So this is the tangent, like this, like this, like this, like this, correct? Now when the observer is here, source is here. Sorry, this diagram, yeah. Okay, here the observer is present, who is at rest. Okay, so can I say this case is related to Bika case? How? Look, observer is here, B is exactly on the face of observer. Here also observer is here, exactly on the face of observer. Means can I say the angle between the tangent drawn on the point on the circle and to the radius, the angle is 90. So can I say even this is 90, even this is 90, even this is 90. So now when this is becoming 90, okay, Can I say here again Vs cos 90 will come into picture? N dash is equals to N into V by V minus Vs cos 90 is coming into picture. Can I say N dash is equals to N? Okay, N dash is equals to N. So can I say no Doppler effect? Can I say? So what we can conclude by this is nothing but when the observer and the source are perpendicular to each other, then there is no Doppler effect. See, this we can say, okay, generally we can say this, okay. So these are the 12 cases that we have seen in Doppler effect. In my next video, there are three more typical cases I'm saying, typical cases left over, which I will cover, and then we will do few sample questions for that, okay. So that's it for today. Thank you. Hope you all enjoyed and understood the concepts.